Selamat datang di channel saya Fisika Rumit bersama guru fisika yang medok. Nah itu ya itulah. Meskipun teacher ini medok, tapi karena di kelas 9 ini ada yang tidak bisa berbahasa Indonesia, jadi teacher akan menggunakan bahasa Inggris selama video ini. Nah, nanti kita akan membahas tentang daya dan energi listrik. Di video kali ini, jangan lupa untuk kerjakan BS-nya. Sebentar lagi teacher akan terangkan kira-kira apa sih yang namanya daya dan energi listrik itu. Begitu ya, jadi cek Google Classroom-nya, cek tugas-tugasnya. Setelah itu nanti kita akan mulai untuk memahami kira-kira apa daya dan energi listrik itu. Oke? Hey, now you see that I am standing here in front of this display, but you can see that there are two light bulbs. The first one is here, the second one is here. Can you see the difference of these two light bulbs? The light bulbs here is a little bit dimmer than this one, right? So do you know why one is dimmer and the other one is lighter? Because it consumes a different amount of energy. So this light bulb here sucks up a little energy than this one. This light bulb needs more electric energy than this one, so it shines brighter than this one because it uses more electric energy than this one. So in every second, this light bulb consumes more energy. So you hear about watt before, right? So there are light bulbs with 10 watt energy consumption and other one with 20 watt energy consumption. This light bulb is 5 watt. This light bulb is 40 watt. So what does it means the watt, and how come 10 watt consumes less energy than the one here with 40 watt power consumptions? Let's move on to the explanation here. I need you to understand it, and if you need to repeat it, you can pause it and play it all over again, yeah? And don't forget to work on your worksheet, okay? So like I told you, you must have heard about watt before. So what is actually watt? What is actually watt? We already see the difference of watt in the light bulb. What is watt? It may sound strange, but we will discuss about what is watt actually. So imagine that there are two light bulbs. The one is 40 watt light bulb, the other one is 20 watt light bulbs. So the 40 watt light bulb will shine brighter than the 20 watt light bulb, right? Because of the wattage. But what is the wattage means to be? A watt is actually a unit. A unit of what? Watt is a unit of electric power. The higher the watt, it means that the instrument has more power than the other one with lower wattage. It means that this consumes more power. And this light bulb is less powerful because it uses less electric energy. So electric power is electric power is the amount of electric energy used by instrument per second. So the higher the watt, it means that the instrument is using more electric energy. It sucks up more electric energy than the one with a low wattage. So let's see this light bulb with a 40 watt power consumption. It means that it is using more, it sucks up more electric energy than this one, right? So we have to talk about the formula also. Electric power, the symbol of electric power is P. Yeah, P. This is the symbol of electric power. The unit of it is watt, while the electric energy, the symbol of it is W. Let's read it, energy, so it's W, and the unit of it is joule. Okay, so don't make mistake with the symbol of electric power and energy. This is the symbol of electric power. P comes from power. The unit of it is watt. While the energy, the symbol of it is W. Energy. There is a W in the front of energy, right? Energy. Okay. So the unit of it is joule. Okay. As I told you before that the energy, the electric power is the amount of energy per second. The higher the energy that used per second, the higher the wattage also, right? So let's discuss about how to find electric energy. The formula for finding the electric energy is the voltage times the electric current times the time of usage. Okay, so this is the formula of energy. How you find energy? By making sure that you use this formula for finding the electric energy. Now let me review a little bit before. So from Ohm's law, hukum Ohm, you know that this formula is used to find the connection between the voltage, the current, and the resistor. And this is the electric energy formula. Okay, so the voltage is the current times the resistance. By replacing the volt here with this, we ended up with a different kind of formula. Okay, so let's replace the voltage with this Ohm's law formula. Okay, I times R, it is the same. Okay, and it is not changed, it comes from the previous formula. So we have another formula for finding the electric energy, right? And then what if I want to replace the electric current? How do you replace the electric current from this formula? It is by dividing the voltage and the resistance, right? So we can change or replacing the electric current too. Here it is. I replace the I or the electric current with this one formula. So yeah, right? I can divide this R and this R, right? And then the formula ended up with this form: V times V per resistance times T. So it is V square per R times T, right? So we have three forms of electric energy formula. Okay, right. This is the first one. So let's change the color. This is the first one. How do you find the electric energy formula? V times the current times the time. The second one is here. So the third one is V square per R times T. Okay, so this is how you remember the formula in Indonesia. This is the electric energy listrik. Oke ya. Cara mengingatnya adalah kalau punya energi maka kita pasti fit. Oke, kalau punya energi maka kamu harus irit. Ya, saya ulangi. Kalau punya energi pasti kamu fit. Kalau punya energi, kamu pasti harus irit supaya tidak habis ya energinya. So, kalau kamu sudah fit dan bisa irit energi, kamu pasti bisa mengingat V kuadrat per R kali T. Nah, ini tidak ada singkatannya gitu ya. Jadi kamu harus ingat-ingat karena kamu punya energi gitu ya. Energi pasti fit, energi harus diirit. Kalau sudah fit dan irit, bisa mengingat V kuadrat per R kali T. So that's it. There are three forms of formula for finding the electric energy. Okay, and then let's move on to this. Electric power is the amount of energy that is used per second. Yeah, that is used per second. So with this formula, with the energy formula, so we can replace the energy with this formula, right? V times I times T per T, right? So we can divide this one. So we end up with this formula for power, right? So the formula of power is almost the same with the formula of energy, but without T. So this is also, if we replace the V with I times R here, if we replace the V with I times R here, right? So you end up with I times R times I, right? So with the same way, if we replace the I with the V per R, you end up with this formula. Just try it out. V square per R without T. Okay, so let's review. Energy, the electric energy, the symbol of it is W. The unit of it is joule. While the electric power, the symbol of it is P, the unit of it is watt. There are three formula for finding the electric energy is V times I times T. V is electric energy, I is the electric current, T is the time of usage. The second way to find it is I times R times I times T. And the third way to find it is V square per R times T. Okay, so there are also three ways to find the electric power is V times I or I times R times I, and the last one is V square per R. So that is how you find the electric power and electric energy. So the example of it, if there is a instrument let's say this light bulbs. Yeah, you connect it with 220 volt electricity, and then it sucks up 2 amperes electric current and use it for 5 minutes. So it means that the light bulb uses the energy is V times I times T. The voltage that is needed is 220. The current is 2 amperes, while the minute you have to convert it to second, because electric energy is used per second. It is 300 seconds, right? So it is 300 that comes from here. You times it up, 220 with 2 is 440, and you times it up with 300, so I will end up with this amount of energy, right? So if you need to find the wattage or the power consumption of the light bulb, the power is V times I. It means that the voltage that is needed is 220 volts. The electric current is 2. It means that this light bulb has 440 watt power consumption. So that is the difference of electric power and electric energy. So don't forget that the W is the symbol for electric energy, the P is the symbol for electric power. Electric power is the electric energy that is used per second. Yeah? Okay, so let's move on to the next explanation. I need you to watch the rest of the video. Okay, bye. So every electrical instrument has different power consumption. For the example, this air conditioner is about 600 to 800 watt, while this lamp is around 18 to 25 watt. We already know that this light bulb consumes 14 watts of electric power, and this water heater here is 800 watt because it heats a lot of water. Okay, but do you know what is the highest power consumption? What is an electric instrument that consumes the highest power in second floor of junior high school? Let's find out. So where are we? We are now in men's restroom. There is an instrument that consumes more power than the other one. This thing. So let's check it out. So can you see the wattage there? 1800 watts. It is insanely higher even compared to the air conditioner. That's it for today. I hope that you can understand the explanation about the difference of electric power and electric energy. Don't forget that you have a worksheet to finish. I need you to check the procedure and the due dates on your Google Classroom. Don't miss it. Okay? I hope you can finish it on time, and I hope that I can see you soon on the classroom, the real one. Okay? See you on the next video. We'll meet you again soon. Stay safe and stay healthy, guys. Bye.